these polysaccharides are again divided into two categories, homopolysaccharides and heteropolysaccharides. Homo means all the monosaccharides are same, or that means that on hydrolysis it gives only one type of monosaccharide, whereas heteropolysaccharides give more than one type of monosaccharides on hydrolysis. Hemicellulose, it's a very large component of plant kingdom. This is an homopolysaccharide. Cellulose भी लिख सकते हो, आप कोई भी example लिख सकते हो, cellulose का example लिख सकते हो, starch का example लिख सकते हो. These are all homopolysaccharides. I just wanted to introduce you to this new component, hemicellulose, pectin. There are so many things in plants. Now, nature of monosaccharides and nature of rings in monosaccharides, linkage between the rings, polysaccharide is whether it is linear or branched, and molecular weight of the polysaccharide. These are the things that are to be studied. Now, first thing first, the first thing is always to find out what are the monosaccharides in it. And to find out the monosaccharides, whatever is the polysaccharide that is boiled with dilute acid. Dilute HCl will break down all the intermediate linkages between, which I yesterday told you that between the two monosaccharides, there are 1,4 and 1,6 linkages mainly, and sometime 1,2. All these 1,2, 1,4 linkages, they get hydrolyzed, and then we get monosaccharides. So the first thing is always to find out the number of monosaccharides. Then the second thing comes is whether the polysaccharide is reducing in nature or non-reducing is in nature. Reducing and non-reducing again means whether the first carbon is free or not. If the first carbon has R substitution, the OH group on the first carbon has R substitution, it will not give Tollens or Fallin reagent test. But if it is free, it will give Tollens reagent test. For example, in case of sucrose, which is a disaccharide, and we studied it yesterday, carbon 2 of the fructose and carbon 1 of the glucose, they are joined together. So both the aldehyde and ketone group, aldehyde of glucose and ketone of fructose is linked. And that is why it becomes non-reducing in nature. But in other cases, where like in maltose, it is 1,4 linkage. So out of the 2 glucose unit, 1 unit has a free aldehyde group or at the 1 position, and that free aldehyde group then can be can react with Fallin solution, and we call it non-reducing. Now, starch is a non-reducing saccharide. It does not reduce Fallin solution or Tollens reagent. It does not form an osazone, indicating that all hemiacetyl hydroxyl groups of glucose unit C1 are not free but are linked with glycosidic linkages. So C1, if it is not free, it will become non-reducing. Starch is a mixture of amylose and amylopectin. Amylose makes 20% of the total starch, and amylose is a component which has 250 to 4,000 glucose units, and they are generally in 1,4 alpha glycosidic linkage. And amylopectin, which makes up out of the 80% of the plant starch, is made up of D-glucose units connected by the alpha 1,4 glycosidic linkage. Another important thing about these two is that one is straight chain and other is branched. So the first thing, hydrolysis, as I told you, the first thing is whenever we have to find out the structure is to give hydrolysis, and hydrolysis gives us D-glucose. So that is decided then that D-glucose is the monosaccharide present in the starch. Then the second step that is done is methylation. There are so many OH groups. So if it is treated with some dimethyl sulfate or some methylating agent, all OH groups become O-methyl groups. And then it is again hydrolyzed. First we do methylation and then we do hydrolysis. Now in a polymer chain, only OH group free will be those which are not included in the linkages, whether 1,4 or 1,6 or whatever linkages, they will not get methylated. Others will all get methylated. So when after methylation, when starch is hydrolyzed, then two types of monomers were obtained. These two types of monomers were 2,3,6 tri-O-methyl D-glucose and a small amount of 2,3,4,6 tri-O-methyl D-glucose. Okay. Now, what does this indicate? Let me give you the structure of this. This is the, if I do methylation of, this is say the structure of starch, glucose unit joined together by 1 and 4 linkage. Now how many OH are free? This is the number 1 carbon. O, next to the O is the C1, C2, C3, C4 and C5. Now there is OH free here, OH free here and OH free here. This OH is used in linkage on this side of the chain and this OH on this side of the chain. Now if I do methylation of this and then do hydrolysis, now supposing it is a chain, so every 1,4 is attached. Okay. Now if I do methylation and then I do hydrolysis of the methylated glucose, then what are the things that I found? The monomer that I get 2, 3, this is 4, 5, 6, 2, 3, 6 trimethyl. Beside that, I get small amount of 2, 3, 4, 6 tetra-O-methyl and a very, very little amount of 2, 3 di-O-methyl. 2, 3 di-O-methyl. Now what, if I'm getting these three, then what does this indicate? Mainly I am getting this first one. What does this indicate? That this indicates that in starch, most of the glucose units, they have first and fourth carbon used up in linkages that gives 1,4 linkages. Okay. Now, second inference that I can withdraw from this is I am also getting 2, 3, 4, 6. 2, 3, 4, 6. Now, supposing my chain is joining with one and other, then the last ग्लूकोस यूनिट, चेन में जो भी लास्ट ग्लूकोस यूनिट होगा उसमें ये फ्री होगा और जो पहला होगा उसमें ये फ्री होगा. ओके, सो इफ दिस इज फ्री एंड दिस इज, आई एम गेटिंग दिस 2, 3, 4 and 6 tetraomethyl. So in one of the units, this one is only used up in linkage and other are in free. That is generally at the present of, this is will be generally at the in the end of the chain. At the end of the chain, there will be one unit in which only one of the carbon is involved in linkage. In between the chain, both 1 and 4 will be involved in the linkage. Similarly, a small amount of this was also obtained, which showed that 1, 4 and 6 carbon are occupied in the linkage. Now this happens that in one part of the starch there is also side chains present, and these side chains are linked through the 6th carbon, and that is why in some of the monosaccharide units this also does not get methylated, because this is also involved in the chain formation through 1,6 linkage. Now this will become clear. So it was starch was found to have two components, and when the two components were separated by separated and analyzed separately, it was found that amylose is a linear polymer in which there is 1,4,1,4 linkage, whereas amylopectin has branched chains. There are linear and there are branches. So when there are linear, 1,4,1,4 is there, and branching, wherever it is, branching starts from the sixth carbon. So here now there is a 1,6 linkage, but rest of the branch it will be 1,4,1,4 and 1,4. Similarly, another molecule, another branch can start from here, and there will be 1,1,6 linkage and other will be 1,4,1,4 linkages. And that is because of this amylopectin, which is having branched portion, the this sixth carbon also gets involved in linkages, and that is why we get that third component, which 2,3-diomethyl glucose. So these three components were obtained, and from this the not only they estimated what kind of structure is there, they can also, from the ratio of these components, it was also estimated what is the chain length or what is the number of branches that are present in starch. Okay. So what were the inferences obtained were that there are in 24 to 30 glucose units in one chain, straight chain, and hot solution of starch when mixed with N-butanol and allowed to cool gives one fraction that precipitates and other fraction that remains in the mother liquor. This showed that starch has two fractions which were recognized as amylose and amylopectin. So amylose and amylopectin were separated using the hot N-butanol solution. Now there are different type of enzyme also nowadays available which can act either on 1,4 linkage or 1,6 linkage. That also gives us an idea of which type of linkages are present in the molecule. Now if you see here, this is the amylose. Amylose ultimately is a straight chain, but its three-dimensional structure is in the form of a spiral. It takes this linkages make them go into a spiral, and this spiral is the reason that starch gives blue color with the iodine, because iodine molecule, they get trapped in this spiral structure of the amylose. The other portion of the starch, which is amylopectin, this is having branched, you can say there is a straight chain and then suddenly a branch starts, and then this is so more like a fan-like structure it gives in the case of amylopectin. And this branching, as I mentioned before also, it is at 1 and 6 position. Now one more thing which though is not here, I would like to mention is the oxidation with periodic acid, which shows that 1,4 linkage is there. Now to understand that 1,4 linkage, now supposing this is my molecule, and if I do HiO4 oxidation, then what will be obtained here? What will I get? There are this, if I do HiO4, now you see here, once this OH is linked here, there is only two OH groups here, right, which are adjacent to each other. There is no other adjacent OH group because all other are involved in linkages. So when HiO4 oxidation of starch is done, then the bond breaks from here, but there are no free acetic acid or acetaldehyde molecules because both of these OH groups are attached to an R, so it will give an here also. And there will be CHO forming here, and there is no loss of any small molecule here on HiO4 oxidation. Now we go to the next portion, cellulose. See, the beauty of this is cellulose and glucose, cellulose and starch both have glucose as their monosaccharides. The only difference between their structure is how one unit is linked to the other. Whereas in the starch, the linkage is alpha glycosidic linkage. In case of cellulose, the linkage is beta glycosidic linkage. Once again, I hope you have understood what is meant by alpha and what is meant by beta. See, OH is, if the, supposing this is my glucose unit and this is the first carbon, then OH is below, this is alpha glucose. And if OH is up, it is beta glucose. So if OH is below here, fourth वाला glucose का OH तो वैसे ही नीचे आता है in case of glucose. So this linkage is like this, and you can see this is a cis linkage. Okay, both the H are on the same side. If it were beta, then OH, one OH on the carbon one will be on the top, fourth वाला हमेशा नीचे ही रहता है. तो यहाँ पे linkage इस तरह से diagonal बनेगा, and there will be one H above and the other H below. The two H will be trans. That is the meaning of beta glycosidic linkage. Now, though these structures are drawn in a different pattern, now this is a chair conformation, but this also shows why this linkage is preferred. When this cellulose, the structure elucidation is all the same, which similar to what I have told you in case of starch. The main difference, as I said, is between the linkage between C1 and the C4, and mostly cellulose is straight chain. It does not have any branches, and the number of unit in a cellulose chain varies from 300 to 2500. It is colorless, amorphous solid with it does not melt, decompose ही होता है, black हो जाता है, चार हो जाता है. आपने देखा ही होगा शुगर कैसे चार हो जाती है, melt नहीं होती. So the important thing about this is the number one carbon. This is the glycosidic linkage, and this is number one carbon. Okay. Here again, this is the one carbon. 1, 2, 3, 4, and they are joined together in in beta glycosidic linkage. इसको हम chair form में भी देख सकते हैं, and let me see if I can show you in another form. Now you can see these are all structures. Anyone we can take. We can either draw in this form or we can draw in this form. Why I have taken this form, that I will let you know in a moment. But before that, you see this structure. This is what I was telling कि एक H ऊपर है, एक नीचे है, और ये diagonal O bond बन रहा है इसमें. This is the structure of cellulose, which shows that beta glycosidic linkage is there. Now, why I have drawn in this form? Because once the bond is formed, and it is a chair form, as we know, actual structure is more like this. It is not like this. This is our Fisher projections. This is the main, the actual structure which comes into 3D में, which we can see. Now, what is beautiful about this beta glycosidic linkage is that once this is linked like this, In starch, it takes the spiral form, but in this case, it takes the fiber straight chain form. That is because there is also probability of hydrogen bonding with this ether O and the OH, which is at 1, 2, and 3 position. This intermolecular
मैम आवाज नहीं आ रही।
Can you hear me now?
Yes, ma'am.
Now I am talking about this some of the questions which which are many times are asked in net exam, etc. One of the question is what happens when equilibrium occurs, why there is one isomer, especially if we talk about glucose. Mutarotation, I told you, occurs. That is because one of the isomer is in a higher quantity than the other. Now, why this happens, this kind of questions are asked. So, the first thing to remember in this is that our glucose is, whether you draw it in whatever form, actually in nature it exists in the form of a chair. Okay, and the carbon 1 has OH group which comes after it forms a ring structure, and this ring is if there is an only OH group here, then if I put this in water, it will open up and may close. So alpha isomer, this is can change into beta, and beta can change into alpha. But if I convert this first carbon OH into O methyl, then this ring becomes locked. And then if it gets locked, two possibilities will be there. Now it cannot open up. Either this O methyl is in equatorial position or it is in axial position. Now, which of these two will be preferred? You can see for yourself that this, if this comes here, then there will be lot of 1,3,1,3 interactions, repulsion interaction between these in this molecule, because there will be a group here, H here, and there will be repulsion with this. And that is why the and there will be lot of repulsion here with 1,3,1,3. But at the same time, this oxygen, it has a lone pair of electrons. They are lone pair of electrons. This oxygen also have lone pair of electrons here and here. There will be lone pair of interaction. So although at first instant it appears that O methyl should be at the equatorial position and the structure should be like this, equilibrium is more in this direction. And the reason that is given, that why equilibrium is this in this direction, that although there are 1,3,1,3 repulsion, there is also a repulsion between the lone pair of this oxygen and the lone pair of this oxygen, which makes this structure less stable as compared to this structure. So this repulsion, dipole-dipole repulsion, is observed whenever there O is between O and this. Now, and this is now depending upon, because of this, the stability may vary. This type of effect is called anomeric effect, where the nature of the ring is changing because of the anomeric, the nature of the anomeric OH group. Then if you are asked about disaccharides, because in the end disaccharide is also written, राइट डाउन स्ट्रक्चर, रिमेंबर दिस स्ट्रक्चर, एंड केमिस्ट्री याद करने की, रटने की जरूरत नहीं है, अभी तक मैं आपको बहुत बार बोल चुकी हूँ. You only need to mug up the structures, how to write. And how to write मतलब आपको मोनोमर्स पता होने चाहिए और लिंकेज क्या है उन दोनों के बीच में. अब ये लिंकेज क्या लिंकेज होगी? अल्फा लिंकेज है या बीटा लिंकेज है? एनीबडी?
Alpha.
अल्फा लिंकेज. एंड व्हाट इज द लिंकेज हियर? लिंकेज का नाम बोलो पहले तो, और फिर बताओ अल्फा है या बीटा है. What is the number of this carbon? This carbon, what is the number? C1, and this is C6. So this is 1,6 linkage. And this is again OH नीचे है, so 1,6 alpha linkage. This is the structure of isomaltose, cell bios. This is carbon 1, this is carbon 4, and H ऊपर है, H नीचे है, OH ऊपर है, beta linkage is there, 4 beta D glucopyranosyl D glucose. This is how we write the nomenclature, IUPAC nomenclature कैसे लिखते हैं. जिसका OH फ्री है, ये हमारा मेन ग्लूकोज यूनिट हो गया. इसकी 4 पोजीशन पे कुछ सब्स्टिट्यूएंट है. 4 पोजीशन पे सब्स्टिट्यूएंट क्या है? एक तो ये लिंकेज बीटा है, बीटा, और ये क्या है? ग्लूकोज मॉलिक्यूल विच इज इन पिरानोज फॉर्म. तो इसको नाम दिया गया है ग्लूकोपिरानोजिल डी ग्लूकोज. ये भी डी ग्लूकोज ही है. तो ये जब डायमर लिखते हैं तो इस तरह से इसका नॉमेनक्लेचर करते हैं. और कोई भी आपको आए माल्टोज, आइसोमाल्टोज या सेल बायोस जैसे डायमर्स, किसी के भी स्ट्रक्चर आपको लिखने आने चाहिए. एंड देन यू कैन शो द ऑल द मिथाइलेशन कैसे होगा, मिथाइल से कैसा क्या होता है, अगर आप पैराइडिक एसिड के साथ रिएक्शन करते हो तो क्या प्रोडक्ट्स बनेंगे, एसिटिक एनहाइड्राइड के साथ करते हो तो क्या प्रोडक्ट्स बनेंगे. 2-3 रिएक्शंस याद कर लो कहाँ पे होनी है, एंड दैट्स इट. देयर इज नो नीड टू मग अप फॉर ईच एंड एवरी dimer, disaccharide or monosaccharide. Another interesting molecule are pectins. Pectin आपने जेलीज खाई होंगी. अब तो आइसक्रीम्स वगैरह में भी यूज होता है. तो जेलेटिन जो जेली है, दैट इज जो प्लांट से आती हैं, प्लांट ओरिजिन की आती हैं. एनिमल ओरिजिन से भी होती हैं और प्लांट से भी होती हैं. द वन दैट कम्स फ्रॉम द प्लांट्स, दे आर कॉल्ड पैक्टिन्स. एप्पल का जैम बहुत आसानी से बन जाता है, एप्पल का, पेयर्स का, बिकॉज दे हैव लॉट ऑफ पेक्टिन इन देम. नाउ व्हाट इज दिस पेक्टिन? पेक्टिन इज ऑल्सो अ पॉलीसेकेराइड, बट इसमें गैलेक्ट्यूरोनिक एसिड है. नाउ D-galacturonic acid, in which carboxylic groups are either partly or completely esterified with methyl alcohol and others. So now you see the difference between this. Only difference it at carbon 6. Carbon 6 में CH2OH की बजाय क्या है? COOH है. And this COOH is what makes it ये और भी डेंसली एक दूसरे के साथ कनेक्ट हो जाते हैं मॉलिक्यूल्स, एंड दे सॉलिडिफाई, ऑलमोस्ट सॉलिडिफाई जैसे हो जाते हैं, एंड दे आर कॉल्ड पैक्टिन्स. नॉट ऑल द COH आर फ्री दो. सम ऑफ द COH हैव COOCH3. So now I think you must have got some idea कि OH group तो होते हैं, but if they are modified either by nature or by men, then we get lot of other interesting materials from the starch and cellulose. And this is where the research is again going on these days in the natural biopolymers, that how we can modify these molecules and get products which have the same strength as the polymers which are coming from the uh, petrochemicals. So this will be a research in the future. A lot of research will go on in this direction, because now we are looking for biodegradable materials, and nothing more biodegradable than starches and celluloses. Some of you might have heard, who are interested in cosmetics and all, they might have heard about this hyaluronic acid. Uh, this is a natural material which is now being used in cosmetics, and it is thought that this can be injected into the joints and the even in the facial tissues, to give more firm skin. सो जॉइंट्स में तो काफ़ी देर से ये यूज़ हो रहा है, हाइलुरोनिक एसिड के इंजेक्शन. इफ समबडी इज हैविंग आर्थराइटिस प्रॉब्लम एंड जॉइंट फ्लूइड कम हो गया है, उसमें दिस इज बीइंग गिवन, इज बीइंग इंजेक्टेड to give mobility to the joints. Then it is also polymer chain which has glucosamine units, and generally the molecular either the linkage is 1,3 or 1,4, and with very long chain structures are there. Another important, which is now very much in market, is sucralase. And sucralase, now even sucralase was, these are artificial sweeteners, but out of these only this sucralase is comes under the category of carbohydrates. Let me tell you, this is the only one. Splenda also is its trade name. Others are not glucose. This is just, I found it interesting, so I thought I'll share with you. The first artificial sweetener was saccharin, but now we know that this is carcinogenic, and this is now, but it is still the cheapest of the artificial sweeteners, and sometimes still used by in poor confectionery or low cost confectionery. Other also came into picture, but then came sucralase, which is having these two units attached with this alpha glycosidic linkage, and there is a CH2OH की जगह यहाँ पे CH2Cl है. It is a chloro derivative, and it is sucralase is 600 times more sweet than glucose, almost 600 times more sweet than glucose. So this is the natural sweetener. Now this is also being, because it is being found that body cannot hydrolyze them. There may be in future some things that might come. Its negative effects. Till now we don't know. FDA ने इसका approval दिया हुआ है, but now we are going toward this stevia जिसको बोलते हैं, which is coming from the plant, but this gives a slightly bitter aftertaste. But sucralase is another carbohydrate which is having a very, very high sweetening properties. So that is about the sugars. Or carbohydrates. I think I have covered them up all. If you still have any doubts or anything that is not clear to you, let me know. Guys, let me know if there is some doubts, questions. तो आपका सिलेबस थोड़ा चेंज्ड है पुराने सिलेबस से. पिछले साल तक मल्टीपल चॉइस क्वेश्चन आ रहे थे, सो नेचुरली द पैटर्न वाज डिफरेंट. This year, what type of question will be asked? That you can check out old question papers for that. कल मैंने आपको एक और पीडीएफ शेयर किया है, and this PDF will also give you a little more in detail so that you can understand the structure of these carbohydrates. Okay. Still, if you have any doubts, you can get back to me. And let me know if any other topic you need, like mass. हो गया आपका या कुछ doubts हैं? तो आप लोग अपना माइक्रोफोन खोल के कुछ बोल सकते हो, कुछ पूछना है पूछ सकते हो. All right then, thank you and all the best.
Ma'am,
Yes.
ma'am, I have a doubt. What to write in derivatives of polysaccharide?
वो मैंने सेल्यूलोज वाले बताए ना आपको.
हाँ.
हाँ, वो लिखिए.
ओके. फिर
डेरिवेटिव.
सेल्यूलोज, हाँ, उसका काइटिन और फिर वो
हाँ, उनकी
सेल्यूलोज.
स्ट्रक्चर. हाँ, स्ट्रक्चर लिख दीजिएगा उसमें.
और
ठीक है.
मैम केमिस्ट्री पूछा है, उसमें भी स्ट्रक्चर ही लिखना है.
किसमें?
केमिस्ट्री ऑफ सेल्यूलोज वो सब पूछा है ना, सेल्यूलोज फिर
केमिस्ट्री ऑफ सेल्यूलोज में, हाँ, सेल्यूलोज की सब रिएक्शंस आपको डालनी होंगी उसमें भी। केमिस्ट्री में एक्चुअली ऐसा वर्ड आना, केमिस्ट्री की बजाय स्ट्रक्चर आना चाहिए था। आई डोंट नो कैसे वो करा है, केमिस्ट्री ऑफ सेल्यूलोज। ये केमिस्ट्री मतलब एक्चुअली हाउ दिस सेल्यूलोज स्ट्रक्चर एंड प्रॉपर्टीज सब आएगा उसमें।
ओके,
हाँ, और ये
थैंक
नेचुरल
यू।
प्रोडक्ट्स की कोई भी बुक ले लो, आपको उसमें मिल जाएंगे। फिर भी अगर कोई दिक्कत आती है देन यू कैन कॉल मी।
ओके मैम,
मैंने,
थैंक यू।
बिकॉज सेम चीज मैं बार बार रिपीट नहीं करना चाहती हूँ। OH ग्रुप की रिएक्शंस हैं या पैराइडिक
हाँ
एसिड की रिएक्शंस है, और उसी से फाइनली स्ट्रक्चर भी डिराइव किया गया है उनका, जो मैंने आज बताया आपको।
हाँ,
तो वो आपको क्लियर हो गया?
यस यस।
ठीक है।
ओके, थैंक यू मैम।